We are going to discuss how to add and subtract matrices in this video. So the first thing, the key here, is we can only add and subtract them if they have the same dimensions. And the reason for this is we're going to add each element with its like element in the other matrix. So if they're not the same dimensions, then you don't have the same number of elements in the same positions in order to add or subtract those. So again, they have to be the same size or the same dimensions in order to add or subtract. So let's look at the first one. We have two matrices. You can see that we have those match, the 2 and the 5, the -7 and the -4, and the 1/2 and the 1. And when I say match, I guess I should be careful. They're not the same number, right? But they're in the same position in their matrix, right? So the -1 is in position A11, and the 3 is in position A11, because both of those elements are in the first row and the first column. So that's what I say when I mean match. So match might not be the best word choice because it's not so clear. But each of the different colors are in the same position in its matrix. We can see that both of these matrices are a 2 by 2. They both have 2 rows and 2 columns. And so because they're the same size or the same dimension, we can add these two matrices together, these two matrices. We're going to have a matrix of the same size as the two that we're adding. So the answer will also be a 2 by 2. So -1 plus 3 is going to go in the first row and the first column. -7 plus 4 is going to go in the second row, first column. 2 plus 5, first row, second column. And 1/2 plus 1 is the second row, second column. And then you're simply going to combine those together. So -1 plus 3 is 2. -7 plus 4 is -3. 2 plus 5 is 7. And then 1/2 plus 1, remember that you can add numbers together. You can make an integer fraction by putting it over 1. And then you'd want to have the same denominator. So the common denominator would be 2. So I would scale the 1 over 1 up by multiplying by 2 over 2. So 1/2 plus 2 over 2 is 3/2. Okay, and so that is your sum. This matrix right here is your sum. Okay, and so it's not necessary to write this kind of intermediate step. You can just add -1 plus 3 is 2 and just immediately go to that solution. But this intermediate step is just so you can clearly see what I'm adding together. All right, let's look at number 2. So first thing is to check the size of each matrix. So the first matrix looks like it has 3 rows and 3 columns, so it's a 3 by 3. And then the second matrix also looks like it has 3 rows and 3 columns, so it's a 3 by 3. Since they are the same size, I can subtract, and remember my difference will be a 3 by 3 matrix as well. So I'm going to have 2 minus 15, so that'll be -13. So that was, I'm going to go down the first column. So I'm going to go down the first column. So 2 minus 15 is -13. Then I have 1/4 minus 5. So 1/4 minus 5, which is the same as 1/4 minus 5 over 1. So again, a common denominator would be 4. I can scale the 5 up by multiplying the top and bottom by 4. So that would be 1/4 minus 20/4, which is -19/4. So that would be A2, 1. And then -1 minus a -3. So be really careful here, make sure you realize you're subtracting a negative. So again, this is -1 minus a -3. So the two negatives make a plus, so it's really -1 plus 3. So that would be a 2. Okay, now I'm going to go down the second column and add corresponding parts, or I'm sorry, subtract corresponding parts. So 3 minus 3 is 0. 2 minus a -1. So 2 minus a -1. That would be 2 plus 1, so that's 3. 5 minus 2 is 3. All right, I'm going to go down the last column and add, well, I keep saying add, subtract corresponding parts. So -1 minus 5, that would be -6. 0 minus 8, that would be -8. And then 2/3 minus 1/6. Again, I have to have a common denominator. Whoops, I don't need to scale that one up. I need to scale the first one up so that its denominator is also 6. So that would be 4/6 minus 1/6. So that would give me 3/6, which is 1/2. And so there is my difference. Okay, the last example that I have is example number 3. And so the first thing we would do is check to see if the two matrices have the same size or the same dimensions. So the first one has 3 rows and 2 columns. So it's a 3 by 2. And the second one has 3 rows and 2 columns. So it's a 3 by 2. So they are in fact the same size, so I can subtract them. So I'm going to do that. Now another way you can do this is you can change this to addition. If you change all of the signs in the following matrix. Okay, so in other words, I can change this to a plus as long as I change all of the signs in the matrix. And then I'm just going to add. I find this easier to do. If it confuses you, then you can either write out the intermediate step or you can do it like we did in number 2. So find a method that works and is not going to confuse you and use that method. So our solution, our difference will be a 3 by 2 matrix. And so now since I've changed it to addition, I have 1 plus a -11. That will give me -10. 3 plus 4 is 7. -8 plus -2 is -10. 4 plus 3 is 7. 0 plus a -6 is -6. And then -2 plus 12 is 10. Okay, so that should be your solution here. So again, the key is, it's not really difficult to do this. The key is remembering that the matrices have to be the same size and your answer will be the same size. That matrix will be the same size as your two matrices that you added or subtracted.